Welcome back, guys. So in this video we're going to be going over logarithmic functions. So I know logarithms or logs are a very bad memory from the past, but let's see if after this video you guys actually give it a shot. So let's get started. So here we have that a logarithm is a blank. So what exactly is a logarithm? A logarithm is just simply an exponent, right? I wish my teacher would have told me that too when I was studying this. So it really just is an exponent. But not just any exponent, it's a specific exponent. So the power to which a number must be blank or to get some other number. So what fits into this sentence? The power to which a number must be raised in order to get some other number. So that's what a log actually is. And soon, with an example, I will show you guys what exactly that means. But now let's talk about how we solve logarithms, right? So logarithms, we actually always solve for them in exponential form. And what exactly is exponential form? It's actually right down here, right? This is how we go from logarithmic to exponential form. So right here we have logarithmic form, log form, and here we have exponential form. So those are the two forms we're going to be dealing with. And why do we deal with logarithms and exponentials at the same time? Why do we even relate them? And the reason is because logarithms and exponentials are, we actually learned about this, and they're inverses, right? So a logarithm and an exponential are inverses, right? So earlier when I talked about the inverse, I gave you guys a reference on the whole y equal to x line, and remember that I drew an exponential and then I also drew a logarithm. So we're going to start off with the classic exponential, and then we're eventually going to turn it into a logarithm somehow, right? So let's do this. Let's here put 2 to the x. Alright, we're going to put 2 to the x, and the logarithmic version of this is going to be log 2 of x. And in a second I'll get into how to do all this. Just believe me for right now that 2 to the x is equal to log 2 of x, right? So let's put in some values for 2 to the x. So we're going to have -1, 0, 1, and 2. Just some classic values I'm going to put in, right? So 2 to the -1 is actually 1 over 2, right? So 2 to the -1 actually gives me 1 over 2. And 2 to the 0, remember anything to the 0 power is 1. So we're going to get 1. 2 to the 1 is just 2. And then 2 to the 2 is 4. So now we have some values to plot here on an exponential. So at -1, let's do this in blue. -1, we're going to go to half. At 0, we're going to go to 1. At 1, we're going to go to 2. And at 2, we're going to go to 4. So you guys remember how the exponentials look like? They kind of just look like that. And now, remember that when I talked about the inverse, I was going to reflect it over this line, right? Well, let me show you guys exactly how we can get some points for logarithmic, and we can just plot those. So when we talked about inverses, right, we just said that a logarithm, that an inverse is just flipping the x and the y's. So in this case, we're going to flip the x and the y's to the exponential to get the x and the y's of the logarithmic. So we're going to put here 1/2, and now it's going to turn into -1. We're going to put here 1, and it's going to turn into 0, and now 2 and 1, 4 and 2. So you see how I switch every y with x's for the logarithmic and every x with y. So now let's plot these points, right? So I'm going to have 1/2 for x, which is here, equal to -1. Then I'm going to have 1, 0, 2, 1, and 4, 2. So if I draw my points, you guys will see, should have actually drawn the exponential in red. So let me go ahead and do that. So I'm going to go ahead and draw the exponential in red, so it matches my coordinates. So you guys see how logarithm and an exponential are actually inverses, right? So that same relation that I'm showing you guys here graphically is exactly what we're going to talk about when we say that we have a relationship between the logarithmic form and the exponential form. That is actually an inverse relationship where we switch x and y's. So let's give this a shot. So in example A, I'm going to tell you guys to find the exact value of log base 3 equal to 9. So back with logarithms, right, I told you guys that logarithms were an exponent. So here the question is, 3 to the what power gives you 9, right? That is the question that is actually given to you in this logarithm when you turn it into like words. So for right now, we're going to say that log base 3 of 9 is equal to a number x. Okay? So we're just going to do that. And then we're going to use our logarithmic to exponential relationship that we have here in red to find the answer. Although we already know what the answer is. We know that the answer is 3 to the what power gives you 9. And you guys tell me what the answer to that is. And that is 2. Correct. So 3 to the second power gives you 9, right? So this whole logarithm, the answer to this whole thing has to be 2. But how do we find that it is not so obvious or in other cases, right? So we need to use, so we go back to this point here where we say that we always solve logs in logarithmic form. So what that means is just that we are going to switch from logarithmic to exponential, and we're going to do just that right now. So first we need to identify every component of the logarithmic, right? So here we have a 3, right, where we have a b, right? So our base of the logarithm is 3, which that's what that means, and then we're going to put the b as the base of our exponential. So in that case, we're going to have 3 right here as our b. Then we're going to have a 9 here. You guys see, which the 9 here is our x, and the x, when we turn it into exponential, goes in the other side of the equal sign. So it's going to go on this side. And last, we have our x here, which is actually just going to be our y, which our y goes as our exponent in the exponential form. So it's going to come up here, right? So if this was a little like too complicated, what I like to tell people is just to think of going from logarithmic to exponential as joining the outsides, and in this case the outsides are the 3 and the x. You guys see how these things are on the outside, and we're going to kick out the middle, which is going to be the 9, right? So we're going to join x to 3, so the outside is going to come in, right? 3 is going to be joined by the x, so x goes on top of the 3, and then we're going to kick out the 9, so it's going to be 3 to the x equal to 9. Or we can just follow the formula, whatever is easier for you. So then right here we have the question. 3 to the x is equal to 9. So what 3 to the what gives you 9? And in this case, it's going to be x equal to 2. Alright? That's how we get it. So in letter B, we're going to have the same question, right? 3 to the what power is going to give you 1. So we're going to write here x, right? We're going to write x. And then we're going to ask ourselves, we're going to do the same thing, right? Well, we're going to go with the whole outsides, insides thing. So we're going to join the outsides, right? So it's going to be 3 to the x. And then we're going to equal it to the inside, when we're just going to kick out. It's going to be 3 to the x equal to 1. If we have any questions, we come over here and we check it with our formula, with our formulas, and we should get the same thing. So 3 to the what power is going to give you 1. So we do remember that anything to the what power gives you 1. Anything to the 0 power gives you 1. So in this case, x is equal to 0 because 3 to the 0 is equal to 1. Alright? So this is how we would solve logarithms without a calculator, right? This is the question of the logarithm. What is a logarithm, right? So, same idea. We're going to go down here to the properties. Okay? So here we have the properties of logarithms, right? So when we're going to talk about the properties of logarithms, they're just like the properties of exponents, but just a little different. So if you guys remember, with exponents, when things are multiplying, they're actually adding. Well, that's the same thing we have here. When we have two factors and I call them factors for a reason, you guys will find that in a second, when I have two factors multiplying, they're actually going to go add. So it's exactly the same idea as exponents, they're just applied now to logarithms, right? So how I like to say this is when you are expanding, which is what we're going to do here, we're going to expand our logarithm. We have 3x, right? We're going to expand it to something else. We need to first identify our factors, right? So here we have a factor of 3, and we have a factor of x. So we have two factors in total. So what I tell you is, grab your log, which in this case the base is 2. So log base 2, leave an open parentheses, and then draw another log for the second factor. Don't worry about the signs for now. We're just going to worry about the logs. So we have two factors, so we need two independent logs. So each factor gets its own independent log. So now the first factor is 3, so we're going to put that in there. So let's put that in red. So 3 is going to come down here. The x is going to come in here. So we have log base 2 of 3 and log base 2 of x. Now what's next? The signs. So now we have when they're multiplying, they're adding, right? But I also like to look at it as a different way. I like to look at it as whenever they're on top, and that means when you have a fraction, right? Whenever they're in the numerator, whenever you have a fraction, they're always going to get a positive. So that's another way of looking at it, right? So whenever we have 3 and x, they're both in the numerator if this were to be a fraction. So they're both technically getting a plus in the front. And that's another way of looking at it when they're adding, right? So let's move on to now to the subtraction. So when we have a division, right, when things are dividing, they're going to subtract. And that is the same thing we have with exponents. Whenever it's dividing, things subtract. So now here what we have is that they each get their independent log, just like for addition and multiplication, but they're going to subtract now. So we're going to get log base 2 and a log base 2. We're going to input its independent things, the 5 here and the x here. And we know that it's subtracting, that the 5 and the x are supposed to be subtracting because we have two factors, right? Remember, we count our factors. But I want to look at it as a different way, so you guys can think about it differently when you have more than just two factors. So here we have log 2 of 5. So where's the 5? Is it on the top or is it on the bottom? It's actually on the top. So I'm going to give it a positive in the front. And where is the x? The x is on the bottom of the fraction, on the denominator, so it's going to get a minus in the front. So although we knew from the beginning that it was subtracting, here we actually have something that could be expanded when we have more than just two factors, right? So we'll get to the more than just two factors in a second, but for now, that was what we need to know for the quotient property or the division. So now, when we have powers, right, our power property, what we're going to have here is going to be that we're just going to, according to this, if you have a power y, we're just going to bring it to the front as a coefficient. So that's all we're going to do here. We have a power 3. We're going to bring it to the front as a coefficient. So our answer should just be 3 log 2 of 5x, right? But now we know just more little than doing that, right? Now we also notice that we have factors inside, that they are two factors that are multiplying. So we have factors multiplying. So what we're going to do is that we're going to break them up. So we're going to have our 3 here on the outside. And then we're going to have two individual logs. They're each going to get their log, the 5 and the x. And yes, they're adding. I mean, yes, they're multiplying, so they're going to be adding. But what we're also going to do is since they're both on top, so they each get a plus in front. So they're actually just adding. Let's take away that plus there, just for notation. So they're still just adding, right? So you can think about it, multiplication means addition, or you ask yourself, where is the log? If it's on the top, it adds. If it's on the bottom, it subtracts. So now we're going to talk about when we have a negative log. All right? So here what we need to cover is that all we're going to do is apply the rules of exponents, which are still going to apply to this, right? So what we're going to do is we're going to apply the rules of exponents, because see here we go from 1x to a negative x, right? But how does that work? If we use the rules of exponents, this is 1 over 2 to the 1, right? But what I'm going to do is I'm actually going to bring it up by making it 2 to the negative 1, right? So by making it 2 over negative 1, what I did was that I just used the exponent rule of the negative exponents and I brought it up. And then I'm going to use the exponent or the power property of the logarithms to bring the negative forward. So I'm going to bring this right here to the front. So I'm pretty much bringing a negative to the front. So I'm going to have a negative log of 2. So I got rid of that negative. Let's use some colors here to my advantage. So you guys see this negative 1. I'm going to bring it to the front. So I'm going to have a negative in the front. So that is just the reciprocal property. Or if I have a fraction, I can just bring it up by using a negative and then just using the actual power property. It's another trick to look at. So now we're going to look at 2 examples in which the first one they're asking me to expand, and then in the second one we're going to see how we can compress. So if you guys see here, you guys are used to expanding because the first thing I teach you. The first thing I teach you is how to expand. So we're going to expand this logarithm, and first what we do when we expand is we count the factors. So let's count how many factors we have here. We have a factor of 3, we have a factor of x plus 1 squared, and we have a factor of y. And what we're going to do is now, since we have 3 factors, we're going to expand into 3 individual logs. Right? And they're each going to go in there, right? The 3, the x plus 1 squared, and the y. So now we're going to put that in red. The 3 goes in here. It's kind of ugly. The x plus 1 squared goes in there. And the y. Now, see, this is where you have 3 factors, and you can think about it, what's multiplying, what's dividing, or you can say what's on top and what's on the bottom. So the 3's on top, so it gets a positive. We're not really going to put it there. Now the x plus 1 squared is on top, so what does it have? It has a positive as well. And now the y is on the bottom, or dividing, it's going to get a minus. So now that we have identified its signs, we have gone through, technically within the first 2 properties, where they're product property and quotient property, where they're multiplying or they're dividing. Now let's check the third property, which is the power rule. So now what we're going to do is we're going to check for powers, and if there's any powers, we're going to bring it down. So here I have spotted out no powers here, but I have a power here, and I have no power here. So since we have a power of 2, we got to bring that guy forward. Boom. Okay? So we're going to have 2 log of x plus 1 minus log 2 of y and log 2 of 3. So we have actually just finished expanding this, because first we use the first 2 properties where they each get their individual log, and then right after that we're going to just break down any powers, and then we're done. After we bring down powers, we're done. Which should tell you something, that since when you bring down powers is your last step, when you're going to go backwards and compress in example 3, that is going to be your first step. But we'll get to that in just a second. Just remember that. Your last step of expansion is your first step of compression. So here we have 2 log of 5 of x minus log 5 of y. So what we're trying to do is, since we have already individual logs, we're trying to make it into 1 log. That's what compression means. We're trying to make it into 1 log. So let's rewrite it here just because I can't really work with it up there. So the first thing we're going to do is, like I said, since the last thing we do in expansion is to bring down exponents to coefficients, the first thing we're going to do in compression is bring up coefficients to exponents. So we do like a coefficient check. Boom, I spotted one out. Here's just one, so it doesn't matter. So I'm going to bring up my coefficients, right? So now this becomes log 5 x to the 2 minus log 5 of y, right? So now that I have individual logs, I go backwards in the sense that whatever has a positive goes to the top and whatever has a negative goes to the bottom. So the reason why I keep using this is because whenever you have multiple things that go plus minus, plus minus, plus minus, you want to be like, oh wow, like I don't want to think about who's dividing or multiplying right now. I just want to know, where do I put them? So if it has a positive in the front, I put them on top. If it has a negative on the bottom, if it has a negative in the front, I put them on the bottom. Boom. Let's do this. So let's just write one big log 5, and then a fraction line, right? And then we ask ourselves, what is the sign in front of this log 5x squared? It's a positive because we can't see the negative. It's a positive. So you're going to go on the top. So we're going to show that imaginary positive now, and it goes on the top. Positive on top. Now this guy has a negative, right? So he's going to go on the bottom. So the y goes on the bottom. And we're done. That's all we have to do. So for compression, we first look out for the coefficients. We bring them up as exponents, and then right after that, we just make it all into one big log, and then we ask ourselves who's on top, who's on the bottom, and then we just all put it together. Okay? So after this, we're going to be doing some practice problems on how to see when we just have more than two things adding or subtracting. We're going to have 3, 4, 5 things, and then you guys have to put them together and keep track of all the little rules here that we just learned. So, with that being said, I'll see you next time.